Okay, welcome. Hello, everybody. Hopefully you can hear me. Welcome to the session, DevNet 2415. I'm going to be talking about operational dashboarding, specifically around the Catalyst 9800. So receiving streaming telemetry from the device, and then what we can actually do with it once we have it. So my name is Jeremy Coho. I'm a technical marketing engineer in the Enterprise Networks business unit at Cisco. I've been with Cisco about 2 years. Prior to that, was working at an education customer, the University of British Columbia. I was working in wireless operations there, so I was maintaining the campus wireless network, about 20 WLC wireless controllers, the 8540s, running AirOS like 8.5 around there, with about 6,000 access points and around 60,000 concurrent users on the wireless network in the peak of the day. Over a 24-hour period, we'd see around like 100 or 100,000, pardon me, 100,000 to 120,000 MAC addresses on the WLAN. So it kind of puts it into perspective some of the scale that I've been working with, which has required me to become what I consider an expert in third-party telemetry and basically looking at KPIs or data points so that I can better do my job running the wireless network so that I'm in front of issues before users start complaining. I just added my colleague Paul Lysander, who's in the back of the room, to the WebEx team space here. So if there are any questions during the session, you are more than welcome to ask them in the chat room there. Otherwise, just put up your hand and I'll get to your question. I do like to keep these pretty informal. We have like a nice intimate setting right here, so it's a little bit easier to ask questions and be interactive. If you do ask a question, of course, I'll hook you up with one of these books. It's the iOS XE Programmability. So it's specifically for anything on XE. So the Catalyst 9800 wireless controller runs iOS XE now. So all of the telemetry that I'm going to be talking about today is not specific to wireless. The use cases are specific to wireless, but the interfaces and the Yang models, the data models, are across XE, so routing, switching, and wireless. If you checked out the agenda, this is what you would have seen. I'm just going to do a brief introduction to model-driven telemetry. Talk about some of the Yang models that support model-driven telemetry. Talk about the collection tools, right? So the scripts, some of the open source projects that we can leverage to help us understand better what's happening with this telemetry data. I do have a bunch of use cases and some demos towards the end, specifically receiving some gRPC telemetry. And we're going to be putting that into InfluxDB and then visualizing that with the Grafana stack. So who's using open source tools like Influx and Grafana or Kibana or any sort of those things? Okay, good. So some of you are familiar with this technology. If not, I will do a brief overview of what the stack is and how we can get started with it. That's the agenda, basically everything that I just said. I'm going to go through the wireless controller. I do have like one marketing slide that I put in here next just to cover about the Catalyst 9800 and the access points that are supported on it. So let's dive right in here. So this is the Catalyst wireless controller. Who's familiar with the 9800? Okay, a couple hands. So let me just do a brief introduction. Who's familiar with the AirOS controllers? Okay, and who's here from Meraki? Yes, okay, just a couple hands, so that's good. I wanted to include some Meraki content, but I never ended up getting time to add it. So this is going to be focused exclusively on XE and the 9800. So the 9800, it's replacing the AirOS controllers, the 8540 and the 5520 and the smaller 3504 as well. So the 9800 comes in basically 3 flavors. The hardware appliance, the 9880 and the 9840. That's going to be a 40 gig and 80 gig model respectively. The nice thing about the 9880, it does have a 100 gig uplink, modular uplink. So if you're in a high density environment or you have lots of APs, lots of controllers, then the 9880 might fit really well in your environment, having that 100 gig uplink. Might be a few years away for a lot of you, or might be closer, depending on your environments. So after the appliance is what I work with mostly, which is the virtual machines. And again, there's 2 flavors of the virtual machines. You can have them in your private cloud, so on-prem, or you can have them in your public cloud, so in AWS today and in GCP tomorrow. We're also working with Azure to get the 9800 added to the marketplace there. So you can just deploy the VM directly from their app store or marketplace or whatever it's called for the different vendors and have the wireless controller in the cloud right away. The third and probably the least used option right now is the embedded 9800 software package running on a 9300 or a 9500 router or switch. So with the 9800 embedded, it's going to be working in SDA only mode. So you need to be using DNA Center with the fabric. Okay, so that's the major caveat there. Now there is one caveat with the public cloud. So it's only supporting flex mode. Okay, so you can't have local mode APs connected to your public cloud controller, and you can't send all that traffic back up to the cloud. However, for the on-prem version of the virtual machine, that supports all modes. So those of you who are familiar with the VWLC or the AirOS VM, you might recall that you can only run that in flex mode, right? So you can't have local mode. Most customers that I work with are going to be using local mode, so all of your access points are connected to the controller and all the traffic is tunneled back to your central controller. So we support that in the virtual machine, on-prem, but not in the cloud. Okay? And the reason for that is that in public cloud, we're paying per GB, right? We're paying for data that comes and goes from the cloud. So tunneling our traffic up into the cloud, a lot of customers don't like that because they're going to be paying quite a bit. So for example, if you stream a YouTube video, you're going to be paying for each GB that you stream from your public cloud provider. So definitely not the model that we want to encourage. However, if there are use cases for that, I'd definitely like to hear that so we can push that forward to the business unit and get that built into the product. As far as the access point support goes, it's relatively simple to remember this. Wave 1 and Wave 2 APs only. So none of the older generation access points are supported. So if you're running 1142s or 3500s, for example, those are not supported on the 9800 platform. Okay, so wireless and model-driven telemetry. This is the protocol stack that's supported on iOS XE. And where I'm going to be focusing today is on netconf and on the gRPC interfaces. So think of this, if you don't understand these or if you haven't worked with these already, think of this like SSH or think of this like the web UI. In addition to SSH and the web UI, now you have a netconf interface and you have a gRPC interface that you can connect to, send commands, and get the device, the wireless controller, to do stuff for you. Now, when you connect on these programmatic interfaces, behind that, there's no CLI, right? You're not sending show commands or configure commands. You're actually interacting with Yang data models. So I'll talk about some of the tools that we can use to interact over the netconf interface and how we can pull down the Yang data models to understand what exactly the KPIs are that we have access to in those Yang data models. On iOS XE, there's kind of two flavors of data models. And most importantly is the native data models. So those map one-to-one to the features that are enabled on the controller or on your XE device. So if you want to go configure an access point, if you want to pull information about your wireless clients that have been connected, you can use a native model to get that information. Now, for the open models, these are the vendor agnostic. So these are going to be features that are consistent across vendors. An example that I like to use for this is an interface. Regardless of if you're using Cisco or another vendor's product, the way that you configure an interface, the data that you need to give it, IP address, netmask, gateway, whatever those parameters are, that's consistent. So then you can use an open model. However, with the native models, there's full support for all the features on the XE platform. And again, for the native and the open models, there's two flavors of data that we can get. We can get configuration data where we actually program the device. Think of this like when you're in conft and you're sending commands. That's when you're going to be using a configurational data model. And then we have the operational data model. So this is going to be like getting data about your connected clients. Okay? Any questions on this before I carry on? This is very fundamental to the rest of the talk because all the data we're going to be getting is from netconf or gRPC. And the data that we're asking for is defined by these Yang models. Come on, no one wants a book? Okay. Is there one? No, okay. So as I mentioned, the configurational and the operational data models. I listed all of them out here in this table so you can just get an understanding of the configuration and the oper models that we've made available. So it's basic stuff, right? Access points, clients, information about mobility when you have anchors set up, information about rogues, RRM, mesh, right? So all the features that you're used to configuring on an enterprise wireless network, you can now pull that information out using these Opera models. Same thing with configuration. So there's a lot of overlap between the operational and the configuration models. So these models, we've posted all of them onto the GitHub page. So if you want to make this real, you can just go wget or clone down the repository, and we list all the models there. So with some of the tools that I'll be showing coming up, you can download the tools, download the models, and you can get started right away with understanding some of the data or the KPIs that are listed in those data models. We can also download these models directly from the device. So if you have a 9800 running, you can go on cisco.com, download the 9800, deploy it onto your VMware infrastructure. There's no licensing required. You can deploy that, give it an IP address, get it on your network, and then you can download the Yang data models directly from the device. So we're making it easy for you to do that, to grab the models if you haven't deployed a controller already. So diving a little bit deeper into the Yang data models, one of the tools that I use is called PyYang or PyYang. And what it is it just walks through the model and it parses it. The Yang data model is text-based, so you can open it up in your text editor and kind of read through the comments and the syntax and understand the data that's exposed there. Or I recommend using PyYang because there's some nice flags that we can give it to help us better understand that data. So for example, here I've given it a tree depth of 2, so I only want to see the top 2 headlines for each KPI that are listed there. So let's actually take a look at one of the data models, run PyYang, take a look at one of the data models, and just see some of the data that's exposed there. Okay, let me escape out of the PowerPoints and move over to the terminal here. So here's some data models that I just downloaded a few moments ago. And I have the iOS XE memory process, right? So I'm looking at the health status of the actual physical appliance or the virtual machine that I'm running, as well as I've downloaded a couple of wireless specific data models here. So the wireless access point opper, so giving me details about the access points that are connected to my controller. The AP types, these come by default, and the wireless types. So when you actually grab this one data model, there's some dependencies. So when we export these Yang models using the netconf interface, using some of the tools, it's not going to give us just that one data model. It'll give us all the dependencies that are required. So what we can do is run pyang -f tree. That's going to print out the model in a tree format. And then we can list the actual model here. So paste that out here. So when I run this, it's going to walk through the entire model and list all the KPIs that are available. I'm going to just pipe this through WC, the word count tool, and we're going to do -L. So just show me how many lines that when I run this command, it's going to return. So it's going to return about almost 1,000 lines or 1,000 KPIs that we can subscribe to specific to access points. Okay? So this is a lot of data specific just to access points. We're not looking at anything about clients or the CPU or memory or any of the other models that I listed like roaming or mesh, for example. This is just about the access points. So let's run this again just through less so that we can understand this and walk through it a little bit better. The very first option that we have is the radio opera data. So if I want to start charting out how many radios that I have in 5 gig or in 2.4 gig, for example, we can take a look at the radio type. If I want to see which ones are enabled, which ones are disabled, or admin opera up, opera down, for example, we can take a look at the admin state or the opera state KPIs. So hopefully just by taking a look at the first couple of KPIs here, you're starting to get a picture of just the vastness of this data and how granular we've exposed. We can go down here and take a look at some of the other KPIs here, like the config data. We can actually tell if we've enabled or disabled TX power level 1 through 8 on each different radio. So from my experience, sometimes we hit bugs on the wireless controller, and there's some weird things that happen. So there's been times where I've had to do screen scraping to understand which access point models were transmitting at which power levels or were configured on which frequencies. So So being able to chart this data with ease now is going to be making my life as a network operator a lot easier. So that's the Pyang tool. Any questions on that before I move on? So on the previous slide, I did list how to install this. You can use pip, easy install, or you can just clone it right down from the GitHub repository. This is an open source tool, right? So no affiliation with Cisco. It's been published for a number of years, and there's a couple of contributors and maintainers for this tool, much like the rest of the tools that I'll be referencing. Okay, so the tools, specifically the netconf tools. There's a nice set of scripts on the GitHub repository, which I think I list in the next couple of slides here, for NCC, or the netconf console set of scripts. It's Python tools that have been written exclusively to interact with netconf. So just like we have tools like OpenSSH, NetMiko, and Paramiko, for example, NCC, or the netconf console, is a tool that we have to interact directly with the netconf interface. And we can do some nice things with this, like get the running config programmatically. We can get just a specific KPI programmatically as well. So if I only am interested in the access point configuration, I can find the XPath or the KPI name for that specific data point that I'm looking for, and just request that at a certain interval. So NCC and the netconf client, those are good for doing one-off GET requests or PUT requests, when you want to programmatically get something or change the configuration on the device. If we want to actually subscribe to Streaming Telemetry, as the subject of this talk is, then we'll have to use another tool that kind of hooks in on top of NCC, which is the NCC established subscription. So it actually calls NCC in the background with some other parameters to get the subscription going and maintain that SSH, that netconf connection. So we can get the WLAN config, as I mentioned. I put the example in here. We can do this live if you like, but I think in the interest of time, I'd like to just carry on. But this is an example of what we can send here. So netconf console, we give it the IP, the username and password, and then we give it the XPath filter. So that's what the -X is up here. And we're saying we only want the config data and the WLAN config entries. So what I'm asking for is what is my SSID configuration? What are the security configuration of that SSID? And some of the other parameters that I've configured. And you can see that the SSID that I've configured here, AWS telemetry, my PSK is up here, and some of the security settings are defined. So a really nice example of this is if I want to run this every day at a certain time to make sure that no one else is logged into my controller and enable the WLAN or change the PSK or change some security settings that are going to impact the users that are connecting to the network. Just one very simple use case of when you might want to pull this information on a schedule. So as I mentioned, these are the links to the tools. So it's on the Cisco DevNet GitHub page. It's been up there for, I think, since last year or the year before. And here's an example of using the NCC established subscription. So we run this command, and we keep the session open. Netconf is very similar to SSH. Uses the same SSH subsystem, but it's independent of SSH. So on your device, if you don't have SSH or Telnet or any options for connecting into it remotely, that's totally acceptable. You can just turn on netconf and it won't open up any other ports for you, just the netconf port. Netconf port, not sure if it's listed here, no, but the default port for netconf is 830, so 830. So if you do an Nmap or you scan some of your devices and you see port 830 is open, that means that it already has the netconf yang enabled on it. So in this example here of running the NCC established subscription, I've asked for, I think, a different KPI here. So I'm asking for the access point oper data now. In the previous example, I'm looking at the configuration data. So I'm looking at the SSID and the PSK, for example, that I've configured for the WLAN. But in this example, I'm actually looking at the operational data. So how many APs are connected, what are the AP names, and what are their MAC addresses. In this example, I'm also getting a periodic update. So every 1,000 centiseconds, okay, so every 10 seconds, I'm getting this information pushed to me or published to me from the controller, and I receive it on my collector. My collector is my laptop or an Ubuntu server. With netconf, we need to keep that session open. We need to keep that SSH type session open. If I close my laptop or if the script Control-C's, you cancel out of it, then the telemetry flow stops. We're no longer going to be receiving that telemetry. Now, for operational purposes, that's not ideal, right? We want to always receive telemetry, even if our server crashes or reboots or goes down for maintenance. As soon as it comes back up, we want to start receiving that data, right? We don't want to have to SSH in or connect in or run a script to dial back into that device to get our telemetry. So how do we deal with that? And that's going to be coming up using the gRPC dial out. So instead of using the netconf interface, we're going to be using the other interface, which is the gRPC. Anyone working with Kibana and the Elastic Stack? Have any log analytics systems deployed for that? Awesome. So I put a couple slides in here just about how to get started with this stack, because I do use it, do use it quite a bit for doing analysis and receiving this type of telemetry data. For those who aren't familiar with the stack, this is the major architectural components of it. We have our controller, our XE device, whatever telemetry that we've subscribed to. It's going to come in through NCC, and we can pipe that directly into Logstash. From there, we configure Logstash to send the data into Elasticsearch, which is our data store. Think of this like MySQL or Postgres. It just holds the data. Doesn't do anything with it. It's just a big data store, and all the data is there. But what actually does access that data and draws some charts and graphs and does the analytics is Kibana. So Kibana calls into Elasticsearch, accesses that data to draw us the charts and graphs. Put a couple reference slides in here, so if you do want to get started really quickly, you can pretty much just blast these commands into an Ubuntu 18 VM, and within like 5 or 10 minutes, you'll be on the road. Your Kibana stack will be fully operational. You can reboot your computer, reboot your VM, and the stack's going to start back up right away. And this is just a static screenshot of what Kibana is going to look like. So in this example here, I have, I'm collecting the AP name, AP MAC address, and I've also subscribed to the client MAC addresses. So I want to understand how many clients that have connected, to which AP they're associated to, and what the MAC address of that access point is. We can also have some line graphs over here. So I'm also looking at the free memory and the used memory of my controller over time. So one KPI or one metric that I used to pay really close attention to was the free memory utilization on the controller. Sometimes there'd be memory leaks on the 8.0 and 8.2 code of the AirOS, and I'd be charting this, and I'd just see the slow trend. Every day the memory would go down, and then eventually there'd be only 1 or 2 megs left, and I could tell my boss, hey, it's going to be a bad day. The controller's going to crash unless you approve this maintenance window tonight so I can preemptively reboot the controller. Right, so this is an example of getting in front of issues where we're watching data and trying to be proactive about not having an outage in the daytime, but actually dealing with that in a scheduled maintenance window. Ideally, we don't have memory leaks in the software and it's just stable, but unfortunately, that's not the reality. And that is getting a lot better with the 9800 being modular. We can actually restart processes that have memory leaks or memory issues and don't have to restart the entire controller and have a whole like 5-minute downtime while that reboots if that's the architecture or configuration. Who's using Splunk? 1, 2 hands, a couple? Okay, good. I wanted to put some examples in here of piping this data into Splunk, but again, unfortunately, didn't get to that because I'm focusing now on the gRPC, the dial out. So probably in the next year when I'm here, hopefully I'm selected to come present again, I would like to put more examples in here of piping this data through other telemetry systems, including Splunk. Okay, so this is like the meat of the presentation now. So using gRPC. So at the very top, we have our wireless controllers. And it doesn't matter how we've deployed these, whether they're the appliances, the virtual machine, or if it's embedded, they all have the same configuration, or the same programmatic interfaces are available, specifically the netconf and the gRPC. So in this configuration, the device is going to push telemetry over this gRPC protocol, and we're going to receive it in a tool called Pipeline. Pipeline, I have a slide coming up about it, where to get it. It's on the Cisco GitHub. And basically, it receives telemetry, it de-encapsulates it, and it sends it out to a time series database. Again, think of this like Elasticsearch from the last example, or think of this like your MySQL. This is your data store. So Influx is where all the data actually resides at the end. And then calling into InfluxDB in this example is going to be Grafana. So Grafana is the visualization front end. This is a screenshot of what Grafana looks like. So kind of similar to Kibana, but Grafana works primarily with numbers, with metrics, whereas Kibana has full text search. So those are the two main differences. So depending on the data that you're going to be looking at, if you want to be looking at a lot of MAC addresses and AP names, for example, then Kibana might be better suited for your needs. If you're going to be looking at metrics such as like DHCP counters or radius counters, then Grafana is very easy to work with and very well suited to work with metrics like that. So Pipeline was developed by the XR team, the service provider team, and it's for receiving telemetry from the XR device, from the router. So I crossed out some of their lines from their quote on their GitHub page to make it a little more vendor or device agnostic, but basically anything that sends gRPC. Now, it doesn't have to be Cisco, it can be any other vendors' protocols that are speaking over gRPC. Pipeline doesn't care where it's coming from as long as it's gRPC, and as long as we've configured the encoding and the encapsulation correctly, which I'll demonstrate coming up. Then Pipeline will receive that data, process it, and then send it out to that time series database. For Pipeline, there's a couple configuration files, specifically the Pipeline configuration. So this is where we say what port we listen on, and what protocol, and what encapsulation we're expecting to be receiving from the XE device. So in this example, it's gRPC, and we're using GPB, Google Protobuf encoding. So this is a binary encoding protocol. It's very lightweight. And there's very little impact to the device that's sending this gRPC, or this GPB encoded gRPC data stream. Unlike SNMP, right? So many of us worked with enterprise networking monitoring solutions, like Cacti or PRTG, for example. There might have been situations where we've added another tool or another SNMP collector, and then we've seen our CPU like double or triple in utilization, maybe even to the point where it's causing network issues. I know there was one example where we were evaluating a new network monitoring tool, and after about 4 or 5 hours of this tool running, all of our switch stacks started having problems, right? So we had to stop that collection and reevaluate how often we were collecting that data and the frequency and how much data we were collecting. So contrast that to the Google Protobuf, which is a binary encoding, very lightweight, using gRPC, which has a very low overhead against the CPU. We can now collect just as much data even more frequently and still not impact the network device. The metrics.json, this is the file that's going to define which data points we actually want to send to our time series database. So we can actually get our XE device, our wireless controller, to send like all of those KPIs, maybe like 900 or 1,000 KPIs, but maybe we're only interested in indexing 5 of those to our time series database. The rest of them are just junk. We don't care about that. We can log that out to just a JSON text file, the dump script, and then we can monitor that to see if there are KPIs that we're interested in, or if we want to add those into the metrics.json file, index those, and then draw some visualizations on those in Grafana. So let's take a look at the actual configuration of my pipeline here. Specifically, what I want to show here is the type of data that we're receiving, which is gRPC, and the encapsulation, which is Google Protobuf. And again, I'm listening on this port 57500. Further down in the file, we actually define where the data goes out to. So here you see that we're going to send the data out to Influx. Influx is on the local host, and the database that I'm going to send it to within Influx, which is MDT config. Now, Pipeline is sending data to Influx, but we can also send it into Elasticsearch. Right? So from the last example of using the Elastic Stack, we don't have to send it just to Influx. We can send it to Elastic. We can send it to Prometheus, Kafka, there's a whole bunch of plugins that you can send this data to. And I also mentioned the metrics.json. So what data do we actually want to keep? So for the two examples that I have here, the memory statistics and the interfaces, I'm only interested in the packets per seconds and the in and out octets. But I'm only interested in the free, total, and used memory. I'm not interested in any other KPIs that come along when I subscribe to this model up here, to the memory statistics. Because there's probably like 20 or 30 KPIs that are available in there. So because I'm only interested in the total used and free memory, let's only send that data into the InfluxDB, into the data store. So let's move over to the Ubuntu VM and take a look at what this configuration actually looks like on my working server here. So I've cloned this down, git clone big money, do a listing of the files here. And let's take a look at the iOSXE pipeline.conf. So I'm expecting to receive dial-out configuration from the XE device. Again, the encoding gRPC, GPB, and I'm going to be listening on 57500. Sending the data out to Influx on that port. If I move over to my wireless controller here, looks like it logged me out due to inactivity, so let me just log back in here. We can take a look at the telemetry configuration that I've pushed down, or that I've configured on this device. So we can do a show telemetry IETF subscription all. This is going to show that I have 5 or 6 subscriptions that I've already configured. Let's take a look at the running config to see what that configuration looks like. So we're going to do a show run section telemetry, and we can look at all the configuration here. So it's pretty straightforward when we're going to be subscribing to data. So for subscription 501, the first subscription that I've added here, you can tell that the encoding that I want to send it is Google protocol buffers. And this is self-describing key value pair Google protobuf. And that's the default and the only option that we have right now for sending data out over gRPC. The filter XPath, so this is the Yang model that I'm specifically interested in, or the KPIs that I'm looking for. So I'm looking at the CPU utilization over 5 seconds. Where I'm going to send this data to, that's the Ubuntu virtual machine. The Yang push, so I'm going to actually be using another Yang model to push that data out. And how often I want that data to be pushed out to me. So again, this is a value in centiseconds. So this is 2,000 centiseconds, or every 20 seconds, it's going to push this data out to my collector. So there's actually 2 options that we have for the update policy. And the one that I've listed here is periodic. So every 20 seconds, we're going to push data out. The other option that we have here is called on change. So only push data when there's a change. For example, only send me an update when an access point joins or disjoins the controller. I don't really need every 20 seconds an update of all the APs that are on my system, because it's going to be the same for the most part of the time. But I am interested in if an access point joins, or if an access point disjoins, right? Something crashed out, someone unplugged the AP or ran off with it, or who knows what. So that's a really nice example of using the on change. So you only get notifications when something changes. Sorry, that was the source address, and this is the destination. So that's the actual IP of the Ubuntu VM, the port, and then we specify the protocol. So again, the gRPC protocol. So what we configure on the right, on the wireless controller, also needs to match what we have on the pipeline configuration. So if I go back over here to pipeline, let's take a look at the metrics.json file. So again, this is going to define the data that I actually index to the data store. And anything that's not listed here is just going to be dumped out to that JSON file, the dumpscript.json, and there's nothing else that we need to do with it. If we do, we can actually include that file in Logstash, for example. So anything that we receive, we can index into another log analytics system, for example. So ideally, this is where I want to set up Splunk and say, Splunk, just watch this dump script, and anything that goes in here, then alert on that, or let me watch that data source. Any question on the pipeline or the metrics configuration here before I move on? This is like, I'm going to have to take all these books home, so no? Okay, I'm just kidding. I actually have books for everyone. So if you do want to grab one before you leave, just come up here and we'll make sure they get hooked up. Okay, so we took a look at the configuration for a pipeline. Probably the last thing to do here is actually go look at the GUI, right? Let's look at the dashboard. This is just a screenshot. This is the same demo that I have running over in the world of solution. So if you go to the far back on the left in the world of solution, the very far back in it's called the reinvent the network zone, you can see this demo and you can interact with it. There's a couple staffers there that understand the system very well, and they can also help answer any questions that you have. So what we're looking at here is all the metrics that I'm collecting through pipeline that have been pushed through that metrics.json file. And now we're displaying them here in the Grafana. So Grafana is a lot easier to work with Kibana than Kibana, in my opinion. Setting up this probably took me like maybe 5 or 10 minutes. The hardest part is knowing which model to select and which KPI to look for. And we'll take a look at the UI right now and take a look at how we can actually create a chart and some of the steps involved in that. So let me just open up the web browser here. And let me just refresh it. So obviously, this is a dashboard that I built up in just a couple of minutes. We're not looking at too much data here, because I'm only collecting CPU, memory, and a couple other interface metrics. So let me go edit this chart. We're looking at the last 6 hours, and this is automatically going to refresh every 1 minute. Let me turn the refresh off just so that it doesn't take away my changes before I had a chance to save it. So the chart that I'm looking at here, it looks like there's 3 different KPIs, and let me select just the 9800. So we can see the CPU on this 9800 is pretty underutilized, right? We're seeing peaks up to 1% utilization. This is a 9800 VM that's sitting on a UCS server with no access points connected. It's basically just a VM that's running, taking up resources, right? And the point is just to show what the metrics are and that we can chart and graph them. So I'm selecting, I'm actually charting data from a 9300 on here, a 9800, and a ISR router. So I've minimized the other 2 devices, so let's only look at the 9800 device. And some of the models that we have access to here, these are going to be the same models that we saw in the metrics.json that we saw configured on the wireless controller. Right, so we have the interface, the memory, CPU, and the IETF interfaces. So we actually have 2 different interfaces. One is the Cisco native interface, and the other is the IETF, or the open interface. They both have very similar data. So once I actually select the CPU utilization, there's another field that we can select, either the 5-minute, the 5-second, or the 1 minute. So if we actually go back to the metrics.json file, we can see that I have the, if we go down here, we should see the 5-minute, 1 minute, and the seconds. So exactly, here's the model, the CPU utilization, and we're only sending 5-minute, 1 minute, and 5 seconds. So that's why when we go into Grafana, we can just select one of those 3 that we've actually indexed into the database. We're also looking at the management traffic, right? So we can subscribe to any of the Yang models that are available. Again, you can download those from the GitHub or export those directly from the controller. Okay, so that's what I wanted to show off. Basically, it's Grafana getting data from pipeline from a 9800 controller. The reference documentation, if you want to set this up, you can go grab the virtual machine and then deploy it. follow this guide to set up the netconf Yang interface. And there's some details about Yang Explorer and some of the models that are in there as well. So the book sprint. This is an exercise that we've been doing in the enterprise networks business for about under a year now. Basically, I think there's about 10 or 12 authors. They call everyone to San Jose, they lock us in a room for all week. We cancel all our meetings, not allowed to take phone calls or go into meetings or deal with any emails. And at the end of the week, we have this nice book here. So there's been 5 in total. I've been fortunate enough to work on 2 of them, worked on this one and the assurance book sprint. They're both really good high-level overviews of the features and capabilities of assurance or of iOS XE. So definitely encourage you to grab a book. And if you're not interested in carrying the book around, or if that's not how you consume information these days, all of the books are also in PDF. So you can go online and just download those, read those on the airplane or before bed or whatever suits your needs there. I did mention this already, the demo in the World of Solution, far back on the left there. Go talk to those guys if you want any more information about the gRPC or the netconf or any of the Yang models related to the 9800 or iOS XE in general. I put a couple of slides in here. This is mostly for myself. These are the sessions that I'm going to go review once they're posted, once the recordings are posted. These are all my colleagues that have put together some good information. This is all related to iOS XE, and a little bit, there's some in here about wireless as well. So I think there's 9 sessions in total across 2 slides here. So this is the second slide. Probably the deployments made easy with Cat9Ks, where they're talking about some of the zero-touch provisioning and the automated workflows that are available on the 9K platform. So that's the 9800 wireless controller, as well as the 9300 switches are probably the 2 most popular products right now. Please make sure you submit the session survey. Probably you've seen this slide. It's Thursday afternoon. It's almost time for the party. If there are any questions, please engage with me either in the Spark room or right now if you see me around. I do like engaging with customers, so if there's anything that I can help you guys out with, then please let me know. But do come and grab a book. Thank you.